All right. Hello, everyone, and welcome to this session on carbon and accounting for cities. So I do want to let you know we have two sessions that have actually been combined into one here, and we'll be splitting out for those. So if you are interested and came for forest carbon accounting, and I would ask you to remain on the live stream. If you are interested and came for learning more about new data sources, supply chain, and connection to sustainable development goals, then you'll want to go over to the Zoom link, which we provided in the chat. And we'll put you into a breakout session there. I do want to just quickly introduce our ICLEI team here. So that's myself, Eli Udall, Kaylin Hart. Kaylin will be leading the forest carbon accounting session, and then Matthew Katz will be with me in the session on data sources, supply chain, and SDGs. So again, if you're interested in the forest carbon accounting, remain on the live stream. If you're interested in data sources, supply chain, and SDGs, then follow the Zoom link in the chat. And I will be heading over, as well as the other panelists for that data sources, supply chain, and SDG session. We'll be heading over to that breakout room now.
Great, and it looks like everyone has headed over to the breakout room. So again, if you are on the live stream, if you are interested in looking at carbon accounting with SDGs, please follow the breakout room, the link to the Zoom in the chat, and you can head over to that breakout room and see that session. In this session, we will be discussing forest accounting, and we're going to go ahead and get started with a couple of our speakers. So let me just get the screen shared, and I'm also going to, this Zoom is also being recorded, so please understand that this will be available to those after the session is over. Great, and I'm just going to go ahead and share my screen. Great, okay. Okay, so we're just going to go ahead and get started. So welcome everybody to the session on taking stock of greenhouse gas emissions, usually in forest and trees outside of forest. So we're going to be discussing how you want to account for forest in a regular greenhouse gas inventory. And today we'll be going over just a few introductions of the speakers that we have today, and then going into the importance of accounting for your forests and trees outside of forests. And we'll get a little bit into what that exactly means in a second here. And going over protocols to help guide you through the process, and a few of the data sources and tools to use. So as Eli had mentioned just a minute ago, I'm Kaylin Hart, Program Officer with ICLEI USA. And with ICLEI USA, we provide technical assistance for US cities. There are other ICLEI offices throughout the world that also provide support to cities throughout the globe, really. And we're really trying to provide the support to cities in order to help them move forward any of their climate plans. And we also have Rich and Nancy on the line. Rich and Nancy, you can go ahead and unmute yourself to just give a quick introduction, and we can continue on with the session.
Yeah, hi, my name is Rich Birdsey. I'm a senior scientist at the Woodwell Climate Research Center, and I've worked in the areas of forest inventory and carbon cycle science for quite a few decades. My role in this project was to talk about forests, where the data comes from, how the calculations were made, and also helped with the reporting and that sort of thing that comes at the end of all of this. So that's it for me. Over to you, Nancy.
Hi, everyone. I'm Nancy Harris. I'm the Research Director for Land and Forest at the World Resources Institute, or WRI, based in Washington, D.C. And my role on this project has been mainly to translate some of the guidance that we have put together for the U.S. Community Protocol into a user-friendly web tool so that communities can use it to estimate emissions and removals from their forests and trees more easily than they could without it.
Great, thanks. Thank you all. So let's go ahead and get into the session. So just advance my slides here. Okay. So when we're talking about incorporating forests and trees, I think we need to just take a step back to really think about what we're really looking at. And we're looking at greenhouse gas emissions and that whether that is from any stationary sources as well as forests and trees. So normally cities and counties and other forms of government will develop greenhouse gas inventories to account for all of the emissions in their boundary. And normally these cities will look at transportation emissions, electricity, natural gas emissions, anything of that nature, as you can see in this chart on the left. So accounting for those emissions. But another part of accounting for the emissions are forests and urban trees. So urban trees are any trees that are throughout a cityscape or in settlement areas. So looking at those types of trees as well. And as we are trying to reduce the emissions that come from your regular sectors as transportation and stationary combustion, we want to look at urban trees and forests as well to kind of help sequester or remove some extra carbon from the atmosphere to help get us to a lot of those targets that we're trying to reach in order to reduce our greenhouse gas emissions. And if I just go back here, this is looking at an example of the US emitting about 6.7 billion carbon dioxide equivalents a year, and forests and trees in the US can account for around 750 million removals of emissions. So we have a little bit of emissions that we can use to help, as I mentioned, get us to that final target of reductions, and helping a lot to get to carbon neutrality or other types of targets. And just kind of breaking down that 750 million removals of emissions for forests and trees. As you can see in this waterfall diagram, we really have a breakdown showing you the different types of trees that help to remove carbon from the atmosphere. And also, if you can see on the right, there's a little bit of emissions actually that come from forests and trees. So what we're looking at here is standing forests and urban trees on these left two columns that are helping to remove that carbon from the atmosphere. But over here in the red, we're seeing urban tree canopy loss or fires or other types of disturbances that are releasing emissions into the atmosphere. And so when we're looking at the 750 million that is taken out of the atmosphere, that is the net between the removals and these emissions. So I did want to get into something that Nancy had mentioned earlier, this U.S. Community Protocol and the Forest Protocol. So there are two protocols that that cities will usually use in order to account for their greenhouse gas emissions. That's the Global Protocol for global communities, and then there's also the U.S. Community Protocol. And adding into the U.S. Community Protocol, other than built environment, so again, that's the electricity, natural gas usage in buildings and transportation, solid waste. Other than that, we have also added the Appendix J with accounting for forests and trees. And that is, again, that's in the U.S. Community Protocol, but the GPC or the Global Protocol will be having some more guidance updated in early 2022 for you all to also use that guidance. But in this guidance, we really wanted to provide communities with a way to estimate their greenhouse gases from forests and trees. And again, that's those removals and emissions from those greenhouse gas emissions. And again, this is just helping to estimate those emissions. So this protocol is not going to provide any estimates for selling carbon credits or specific mitigation activities, things like that. It's mainly looking at how you can account for these greenhouse gas emissions. And so I wanted to just kind of go into the beginning stages of how you go about really accounting for emissions and removals in an inventory. And so that really starts with looking at your looking at what years you want to conduct an inventory for. So as I mentioned, a lot of those greenhouse gas inventories that cities will do are annual. So just looking at 1 year. So for example, if a city wants to look at a 2018 greenhouse gas inventory, that is the standard for doing a regular greenhouse gas inventory with buildings and energy and transportation. And that will help them to develop a greenhouse gas inventory looking at those sources. But with a forest and trees inventory, we have to look not only at land use. So if there's standing forest or trees, and those trees are sequestering carbon or any removal from carbon from the atmosphere, we need to look at that land use as well as the land use change. And so, as I mentioned before, something that could cause emissions, leading to emissions, would be a fire or harvesting any trees from forests. So that leads to emissions. And as well as planting new forests, that can lead to adding more carbon removals to your forest. So really, when we're looking at doing a forest and tree inventory, we need to be looking at that land use change as well. And so because of that, because we need to look at the land use change, we also need to be looking at 2 different years and comparing the change between those 2 different years. So, you know, in the regular inventory, you're just looking at, say, 2018. But when looking at a forest inventory, you'll want to be looking at 2 years. So this example has 2000 and 2010. So we're looking at those 2 years and the change that happened in between those 2 years. And any disturbances to that will define any emissions and any planting of new forests that could add to any sequestration. And so what I mean by looking at change. So this is an example of the city of Los Angeles in California. This area obviously experiences fires and in this drought climate, they experience a lot of fires. And so what we're looking at is, as you can see in this graphic, as it's kind of moving between the years, is The forest areas are changing and being reduced. And so when those forest areas are being reduced, you lose that sequestration, but you also are getting that emission from the fire, emitting the different carbon dioxide into the atmosphere from the fire. Another change could be just looking at, as I mentioned, just forestry over time. If forests are growing and cut over time, there's going to be a mix of emissions and removals in that change as well. And as well as in, this is Lewisburg, Pennsylvania. This is looking at just really no change really, and it's looking at just a forest over time. So this is just a kind of helping to account for the removals that are accumulating over time. And so when we're looking at those changes in emissions, so changes in land use is what we're looking at, and any land cover that we're looking at the change in that, whether that's going from a forest to settlement or forest to cropland, forest to grassland, anything like that. We're looking at those changes, and these are the broad categories for the IPCC. And so we're looking at the changes for accounting for these forests and trees. So an example, if you have a forest that is cut down and put down for settlement, for new housing or other commercial areas, that will result in some loss of sequestration and some emissions, because we're losing that carbon. And so we're trying to look at these different these IPCC land use categories and changing between them, and that can help us to determine what the emissions are. And when we're looking at what the emissions are, this is getting a little technical, just a little bit, but this is a simplified matrix that can help you to understand what changes are occurring. So this matrix is looking at hectares of land. So hectares of forest, hectares of grassland, cropland, anything like that. So as you can see on the left, this column is looking at 2011, what the hectares for this specific community were of forest, what it was for grassland. There was no cropland, and then looking at wetland and other areas. And then this row at the top is looking at 2016 and what the hectares changed into, like looking at the change in that. So if you're looking at just this square from changing from forest land to forest land, there's 43,000 hectares of land that we have that is basically forest land that remained forest land. And so that still accounts for any sequestration or removals of emissions. But when we go to the right, to this 142 hectares, this is looking at a change in forest land to grassland. So that will result in a little bit of emissions into the atmosphere. But if you go down to this 273, this is looking at grassland that went into forest land, changed into forest land from 2011 to 2016. And so that's kind of how you read this matrix, and that's kind of how you kind of develop some of your activity data for greenhouse gas accounting, and we'll get into that in a bit. But so again, these are the main categories of the IPCC categories. And as you can see, that these are the trees outside of forest, which trees outside of forest really make a large portion of the matrix. And you also would want to be accounting for any trees outside of forest that are accounting for any removals and emissions as well. So I'm just getting into, again, a little bit technical, but the actual process, the process of calculating these emissions. So again, for a regular greenhouse gas inventory, we're looking at energy, the natural gas usage and electricity in buildings. We're looking at transportation, waste, things like that. And that is simply taking some like kilowatt hours of energy or therms of natural gas and multiplying that by an emissions factor. But with forests and trees, we have hectares, as I was mentioning in the last, that matrix, those hectares, that is your activity data that you'll be looking at for forests and trees. And so when we are trying to account for emissions and removals, instead we'll have both an emission and removal factor, rather than with just the other energy and transportation sectors that just have the emissions factor. We have those two factors here, and Rich will kind of get into more of those factors in a bit here. But I just also wanted to cover a little bit of what the activity data looks like. So those hectares that I was mentioning for your forest inventory. And this is kind of looking at, you can get your NLCD data and kind of take that into an aggregated IPCC map of the different types of categories. So as I mentioned, those categories on a previous slide: settlement, grassland, cropland, wetlands, and just getting those hectares. And that would be your activity data. And I'm gonna go ahead and pass it on over to Rich to kind of go a little bit, do a bit of a deeper dive into the fluxes of greenhouse gases in the tree sector and get into those emissions and removal factors. So Rich, take it away and just let me know when you want me to advance the slide.
Okay, got it. Yeah, hi everyone. Just wanted to start with a little bit of terminology because there's a lot of terms thrown around and sometimes it's not always obvious to everyone what they mean, but they fall into two broad categories. That's when greenhouse gases are moving from the atmosphere to the atmosphere from the land, and the opposite case is transferring greenhouse gases from the atmosphere to the land. And so if greenhouse gases are coming from the land to the atmosphere, then there's four ways those are sometimes depicted. It can be called an emission, it can be called a source, it can be called a loss, and that refers to a change in carbon stock. So if trees are harvested or damaged, they might be called a loss. And it can be a positive number. So the convention for reporting is that emissions are given a positive number. In contrast, if the CO2 or other greenhouse gases are transferred from the atmosphere to the land, it may be called a removal. It also may be called a sink. You've probably heard about the land sink or the forest carbon sink in the United States, rather significant. And when calculating change in carbon stock, it might be called a gain instead of a loss, which would be an emission. And the convention for reporting is it's a negative number. So I might be using some of these terms slightly interchangeably, and just have to just think a little bit about what each of them means. Okay, next slide. Okay, a little cartoon of the forest carbon cycle. Forests are very dynamic, and there's a lot of stages in their evolution, often starting in this case from a rather mature forest that's growing and sequestering carbon or removing CO2 from the atmosphere. And maybe there's a fire or there could be some harvesting and the carbon gets released. But then the forest regrows and begins to take up carbon again. And so we really try to capture these dynamics in our carbon accounting. Next slide. And this is a bit more complicated diagram of the carbon cycle. And there's a lot of different carbon pools, pools being the words inside the boxes. So a pool would be carbon in leaves, carbon in wood, carbon in the roots, carbon in litter on the forest floor, carbon in dead wood, and then carbon in the soil. And then the emissions or removal are usually describing the transfer as we showed in the previous slide. The point here is there's a lot of moving parts in a forest, and this really introduces a bit of complication to making the estimates because each of these pools and fluxes operate in over different time frames, requires a lot of data to keep track of each of them. And they're all somewhat important depending on the type of activity that's taking place. For example, a harvest of forest would be different than a land use change. And so keeping track of all these different variables is really a central part of doing the carbon accounting for forests. Next. Oops, sorry, my screen locks up every once in a while, but I have a separate one here. So there's different ways of reporting or different levels of detail, and often all we really need to know about is what's going on in the ecosystem, and then what's going on with harvested wood products, the carbon that is retained there. But in calculating emission and removal factors, we go to another level of detail, and we look at 3 carbon pools in the ecosystem, and that's in the center set of boxes. So live biomass, dead biomass, and soil organic carbon. And then for harvested wood products, we estimate the amount of carbon that's retained in the wood while it's being used, and then how much is retained when those products are discarded into a landfill, and how long that carbon retains there. And in turn, the data we use to make these, to estimate these emission and removal factors is even more detailed. And I won't read all those categories, but you can see that when you're actually trying to measure this out in a field or a forest, it requires a separate effort to look at each of those carbon pools in the green boxes. Next. So removal factors, generally estimated in terms of metric tons carbon per hectare per year. And we have several different categories, but these, and these are the 3 types of activities that we estimate removals for. These are undisturbed forests that remain forests. So the matrix that Kaylin showed, this would be that box in the upper left-hand corner, forest remaining forest. And we look at these by region, forest type, and age class, because removals, the estimated removals are quite different across the country and by different forests and what their condition is. And then non-forest converted to forest, and that's tree planting or natural conversion of, let's say, cropland or pasture back to forest. And these are also looked at by region and forest type, but just for one age class, since we're accounting for periods that are less than 20 years, we only estimate the first broad age class, and then later on, if that area is inventoried again, it becomes forest remaining forest. And then there's trees outside forest, and there's kind of a whole separate set of factors that have been derived for trees outside forests based specifically on measurements of individual trees in urban, suburban, and other areas that don't qualify as forest, but still contain trees. Next slide. So here's where the data comes from for forests. It's repeated measurements of sample plots. Across the US, there's about 150,000 of these sample plots. They're measured anywhere from every 5 to every 10 or so years. This is a very large program conducted by the US Forest Service. And if you add up all the trees that are measured, they're in the millions. So there's this vast database that's used to make these calculations. We can't measure everything as well as we can measure trees. And so some of the carbon pools are estimated based on other variables. For example, it's very difficult to measure soil carbon or the change in soil carbon over time. And so there are some empirical models that we use to fill in those gaps where measurements are very difficult to take. And then in doing a greenhouse gas inventory, we provide nationally based estimates with a lot of regional and local applicability, but still there may be local data available that's either a community wishes to use for some reason, perhaps consistency with previous work, or it may be that local data is more reliable than deriving this estimate from a national database. Next. So removal factor is the change in carbon stock per year, generally calculated at the difference in carbon stocks at 2 times divided by the number of years. So the graph at the lower left shows, for one example, how carbon stock changes with age, and it's an increasing function over time, with the increase generally a little greater in the early decades of a forest as it grows, but as it gets later and the forest gets older and older, that growth rate slows down. So if you convert that stock estimates to a stock change estimate, the lower graph on the right shows how that changes over time. So you get a larger number between ages, let's say 0 and 20 or 30, compared with the estimate that would be useful between, roughly about 30 or 40 up to 100 or so. And then it starts to get kind of variable as the forests get older, largely because there's much less data about older forests, simply because they occupy less of the land base. Next. And so when we do our calculations, we provide 3 removal factors for each area. And these are weighted by the area that they occupy. And so we have factors for the 0 to 20 age class, the age class 20 to 100, and then another factor for ages 100 plus. And this works actually quite well. It matches up with more detailed inventory data, and it simplifies the calculation process. Next. So I mentioned we calculate these by region, and so these are the looks like about 11 regions that we use in the US, and they're selected because they're relatively uniform within the region, but rather distinct from neighboring regions. And so they make useful breakdowns to make these, for making these calculations. Next. And we also look at forest types, and you can see by this map that in different parts of the US, there's really quite different mixes of tree species, which determine forest types. And so since emissions and removals are highly variable for different tree species, this is a useful way to summarize the data by different forest types within regions. Next. And then age, which I also mentioned. You can also see here from this map of forest ages that there's a great deal of variability across the United States and well into Canada in this example. But forests in the southeastern United States tend to be much younger than other regions. The northeast and north central regions tend to be a little older. So those are the green colors. Although there's quite a lot of variability there as well. And if you look out west, there's even more variability in age structure, with a lot of areas being quite young. These are forests that have been impacted by disturbances such as fire, insects, or harvesting. And they're in the process of regenerating. So those would show up as kind of an orange or red color. There's quite a lot of older forests, and these are forests in 100 or more years old, and they're in the blue colors, and then quite a bit in between. So it's a very diverse landscape in the Western United States, comparatively speaking. Next slide. And this just shows the age class distributions that I just mentioned very briefly, indicating how they differ by regions. With eastern forests tending to be either younger or middle-aged, and western forests often having a kind of a divergent distribution, with both numerous forests in young ages and in old ages. Next. And so when we put all that together, here's a map of the removal factors calculated from all of those maps and the data from the inventories. And again, you see a lot of variability with the, and remember, the removals are negative numbers. So the larger negative numbers running from -7.5 to -3.6, these occur in the Pacific Northwest and in the southeastern United States. In contrast, the slowest rates of removal, which are the smallest of the negative numbers, they occur in the drier parts of the country, largely in the southern Rockies, northern Rockies, the east side of the Cascade Mountains in Washington, Oregon, and Northern California. And then there's an in-between group, kind of in the Midwest, the Lake States, and Northern Maine, that are have removal factors somewhere in between the extremes. So this is what goes into making the estimates. And again, it's important to know where the estimates are needed in order to capture this large degree of variability. Next. And this is an example of what the removal factors look like by the two different forest types. Looks like it's from the either the northeast or the Lake States, the 3 age classes, and you know, the quantities that are estimated as removals for forest, remaining forest, on the 2 columns to the right there of the table. Next. The question has often come up about using these regional numbers or something local. And again, this is probably a little repetitive here, but regional values are mapped according to forest type and age. And so they work quite well for forest remaining forest in most communities. However, if there's a local source of data, you might want to take a look at it, either to validate that the regional factors are good, or you may have a reason to prefer to use them and substitute them in calculations. Next. So emission factors. So this is the opposite from the removal factors. And we have a number of additional categories here. And they're in metric tons carbon per hectare. Note that there are not carbon per hectare per year, but they're considered a one-time emission or emissions over a rather short period of time within the inventory period. In other words, these events happen sometime within the inventory period that Kaylin talked about at the beginning of her part of the presentation. So we look at forest converted to non-forest, which is a land use change. We look at loss of individual trees outside forests, which is not necessarily a land use change, but it's a certainly something that happens to trees often in areas, particularly urban areas where trees die at a fairly high rate. And then we look at three categories of natural disturbances. That's fire, insects, and weather. And finally, we look at harvest disturbances. And all of these are estimated by forest type and age class, with the exception of trees outside forests. Next. So in forest remaining forests, we really only look at moderate to high severity disturbances. And these are disturbances that actually kill a large proportion of the trees in the areas affected. The low severity disturbances generally have a minimal effect on carbon stocks, and these might be something like a surface fire that burns underneath the tree canopy. It might remove some litter and small shrubs, but the effect on the total stock of carbon is very minimal because the trees are not killed. So we only look at the high severity disturbances. We multiply the area disturbed times the change in pre-disturbing carbon stock. And then the change in carbon stock is estimated from simulations of how forests respond to different disturbances by region, forest type, and age. And this helps make the estimates appropriate for the local area that's being inventoried. Next. So for forest converted to non-forest, what we put into the inventory calculations are estimates that have been compiled for the US as a whole based on literature reviews. And there's three carbon pools. There's the three I mentioned very much earlier in the talk: biomass, the dead organic matter, and soil organic carbon. And then forest converted to different non-forest uses. There's some variability in how these carbon pools are affected, and so we try to capture that with some rather simplified assumptions, and partly because there's not a lot of good data locally on how these different carbon pools are affected. Again, if there's local data available for the amount of biomass loss in particular, this can be used in place of the generic or default estimates. Next. Next slide, please. There we go. All right, when you add all the carbon pools up, we can get some very nice maps based on the forest inventory sample plots that I talked about earlier. The researchers use a process called imputation, where they look at a number of variables associated with each sample plot and then map those out across the landscape. Since the forest inventory plots are scattered rather widely, this allows the researchers to fill in a map of, in this case, total carbon density based on the forest inventory plots. And this is where we're moving into using the tool, because the LEARN tool is really based on maps, not the raw inventory data. But those maps are derived from this whole process that I have just described at some length. Next. Oh, well, we're to the Learn tool, so I guess it's time to turn it over to Nancy. So Nancy, go for it.
All right, thank you. So those of you who are still listening, I think Kaylin and Rich threw a lot at you. And so in developing this protocol and all the methods and the data that Kaylin and Rich just went through, we piloted those methods and data with a set of test communities and quickly realized that a lot of this information is just sort of a lot to digest for many communities who don't have the expertise or the resources to be able to do many of the calculations that would be required to include forests and trees into the inventories. As Kaylin mentioned, forests are different from other sectors. They're more complicated, and so what can we do to make the process of including forests and trees easier on communities to include in the inventory? And so that's where this web tool that we developed comes in. It's a website that lives on ICLEI's main website called icleusa.org/learn. And the Learn tool stands for Land Emissions and Removals Navigator. So it's a fun little acronym. And if you navigate to that site, you should be able to do exactly what I'm doing here in this demo that we'll go through. So if you go to the next slide. So when you get to the website, there's a little landing page there that describes what the tool is and how it's used. It's free. It's free to use for any community within the United States. Next. Okay, so if we launch the app, I don't think this is shown here, but if you go to the website, there's an initial sort of product tour that goes through the overall workflow, which is essentially what I'm going to go through right now, which is essentially 4 steps. The first step is to select the area that you want to analyze and navigate to your own community. Second step is to pick the time period that you want to analyze. And the third step is to review the carbon factors that Rich was just mentioning in his portion of the presentation. And then after those 3 steps, the final step is to view the analysis results. So I'll go into a bit more detail on that, but first, before I show that analysis workflow, I'll just talk through some of the default map layers that are built into the tool that are used to develop the data needed for the activity data that Kaylin was mentioning on all of those land use class transitions, and then the emission and removal factors that Rich just went into detail about. Okay, next. So the main data source used in the Learn tool is the National Land Cover Database, the NLCD. And that is available for different years. So in the Learn tool right now, all available years are in there from 2000 through 2016. And 2019 was just released this summer. And so we're in the process of updating this tool to include that latest year of land cover data. And if you go to the next slide, you can zoom in anywhere in the conterminous US, and you can see all of the county boundaries on the map as well. So if you wanted to look at more specifically at land cover within your community, you can. Next. And as I mentioned, there are different land cover years available. So I think what's shown is 2016, but you can go back in time to look at other years as well. Next. And then if you click on this little eye that has the arrow, you can see what the source of the data is, what the resolution is, all of the metadata associated with that NLCD layer. Next. So in addition to the NLCD land cover maps that are used to calculate land cover and land cover change, we also have tree canopy, also produced by the NLCD, the National Land Cover Database product. And the changes in tree canopy are used for trees outside forest. So the Learn tool really breaks down the calculations into those that are occurring within forests that are staying forests and converting from and to forests. And then we have all these trees that are occurring across all the other land cover types like croplands and grasslands and wetlands. There are trees there, and the tree canopy product is capturing that. Next. And then the third main data set that the tool is using for the area calculations is this map on forest disturbances. So you can select the inventory period that you want to look at, and only the disturbances that occurred within those years will occur. So we have disturbances that happened in forests related to fire, to insect damage, to harvest for the specific NLCD years that you're looking at. It's a little bit hard to see this layer at the national scale, but if you zoom into the map, you should be able to see the areas of forest and harvest and the fires that have happened. Next. Okay, so that's sort of a tour of the data layers that are in the tool. So now once we're ready to start diving in and selecting an area to analyze, you can type the name of your county into the box, and you'll find a drop-down menu that you can select your county. So here, the example is Oneida County, New York. But if you have an area that you want to analyze that's not a county, you can also upload a custom shape file into the tool, and that will be the boundary for analysis. So the default is to run this analysis at the county scale, but other options are possible. Next. Okay, so the step one is selecting where you are. Step two is selecting when you want the analysis to run, which years. And so you can select for the land cover data and the tree canopy data, you can select your years there. Next. And by clicking next, and after you select the years that you want to analyze, a couple of things are happening in the tool. So the selection of inventory years kicks off a lot of the geoprocessing happening in the background. So all those land cover change matrix calculations and tree canopy change calculations that are happening on the activity data, those are happening on the fly in the tool for the specific county and years of analysis that you select. And then those areas of all of those land cover changes and tree canopy changes are then matched with the information that Rich was mentioning about forest age and forest types of forest disturbances to estimate the emissions and removals associated with the forests within that community boundary. So the tool is really doing all of the work that Rich and Kaylin just mentioned about matching all of the pixels together with the activity data and the emission and removal factors so that we get this greenhouse gas result at the community level. So all of that geoprocessing is happening in a couple seconds, depending on how big your area is to analyze. So some of the larger counties out west take a little bit longer than the smaller counties in the eastern half of the US. So once that processing is done, the next step is to review all of your carbon factors that get combined with the relevant areas to do the GHG calculations. And part of the process for assigning emission and removal factors for that trees outside forest piece is related to selecting a location or a city that's closest to your community. If any of you are familiar with the iTree suite of analyses tools produced by the US Forest Service, this is essentially doing the same thing as iTree, but using the tree canopy data from NLCD, and the emission and removal factors that are baked into iTree are also here, which are based on cities and states in which the area is located. So, and if I'm in Oneida County, New York here, I'm picking Syracuse, New York as the closest city, and that tells the tool which emission and removal factors to use for trees outside forests. Next. Okay, oops, yeah, next. So there's also all of the default emission and removal factors that Rich was mentioning, how those are developed from the Forest Service data. Those are all displayed if you expand these menus here. Next, you can see all of the default regional emission and removal factors that have been calculated for you based on the available data. And one of the updates that we'll build into the Learn tool at some point this year is for you to be able to essentially override those defaults with your own data if you have it. And if not, you can just use the regional defaults. Next. Okay, so once you kind of go through this workflow, you can look at the summary table of results that breaks down all of the calculations into that net number at the bottom is the net greenhouse gas impact of the forests and the trees in your community, broken down into the categories that led to emissions and then the subcategories that led to removals. But that bottom net number is sort of the summary. And then in addition to that summary table, if you click print report, the tool will automatically generate a PDF for you that you can share with others in your community. Next. And it looks something like this. And the main summary table that's developed or just displayed in the web tool is also reproduced in the PDF. But in addition to the summary results, we also have some text summarizing the main high-level findings, as well as a lot of information about what data inputs are going into those summary calculations. So what is the land cover distribution of your community? What does that map look like? What are the emissions and what are the removals? How much forest is lost and gained in your community? So you get a really succinct summary of the land cover and GHG situation in your community with very little effort. Next. And then at the bottom of the tool, there's also a resources page. So all of the documentation of the data that go into this tool, additional guidance materials that communities might want to look at to understand where some of these numbers came from. We compiled a set of FAQs or frequently asked questions as we started piloting this guidance with many of the communities that we worked with. We recorded a lot of the questions that we got that we figured many other communities would also have as they went about putting their inventories together. So those would be good tool to for communities to look at if you're starting to think about putting an inventory together. Next. That's it. Kaylin, you're muted.
Thank you. I was really just saying thank you so much to both Nancy and Rich for participating in this and giving that very essential information. And again, the Learn tool has been very beneficial for a lot of our US communities that want to incorporate any forest and tree inventories into their greenhouse gas inventories and into their climate action plans. So again, thank you both for your presentations. And now we're just going to move a bit into kind of what it looks like after you complete this inventory and you add your forest and tree inventory to your regular inventory with your energy and transportation and waste emissions. And so, advance my slide. An important aspect of developing a climate action plan is developing targets. So how are you going to reduce your emissions? What are your goals? What are your goals for reducing your emissions? And just two targets that we're going to be just talking about are relative and carbon neutrality targets. So relative target is what we've seen a lot of US communities setting, which is like a say an 80% reduction from 1990 levels to 2050 for their inventory. And that target, as well as carbon neutrality, is another important target that a lot of communities are looking at. So that's we're looking at carbon neutrality by 2045 or by 2050. And so when we're looking at those targets, when you set those targets and you're trying to figure out how exactly you're going to reach those, we're looking at the different types of emissions, how much emissions your goal is, and then how the forest removals, how those net removals can apply to your overall emissions. And so when we're looking at relative targets, there's the chart on the left is what we're looking at right now. And this is a relative target. So again, this one is actually a 50% reduction that we're looking at here, with baseline emissions of 100 metric tons of carbon dioxide equivalents, and the goal, that's a 50% reduction, so 50 metric tons of carbon dioxide. And so that is what a normal goal would look like if you were not to include any forest sink net removals in your inventory. If you were to include that, that would just kind of help you on the way, kind of as you know, we've mentioned that these forest removals are really that last mile of helping you reduce those targets. So if you have your regular baseline emissions of 100 metric tons of CO2e, and you have a little bit of forest net removals as well. So this is looking at about 10 metric tons that are, again, this is all relative example data, not just examples for this presentation. So 100% or 100 metric tons for your baseline, and 10 metric tons of carbon removals from your forest. And so when you apply that 50% reduction, instead of having to reduce 50 tons or get to that 50-ton reduction, you only need to get to that 45-ton reduction because you have that other reduction from your forest sink. So that's kind of how you can incorporate forest and trees removals into your target when you're looking at a relative target. But then when we're looking at a carbon neutral target and trying to reach those, a lot of them can be net zero targets. If we're looking at a net zero target, and that is just completely reducing your emissions, completely reducing them. So looking at the left or the graph on the right, starting with the without sink, you have the 100 metric tons as your baseline, and your net zero target is to just get to zero by whatever date you have, just to get to zero. With that sink, once you kind of add on that sink, you know, your goal is still to become carbon neutral, and the sink can kind of help to add to your removal. So this is showing that there's about 15 metric tons of removals that are occurring from your trees, your forest, and your trees outside of forest. And so because you have that, to reach your actual net zero target, you only need to reduce 85 tons of metric tons of carbon dioxide equivalent. So that's kind of how you incorporate these forests and trees outside of forest into your targets. And then you can go on to planning. So we really like to stress that again, the trees and the sequestration or removals happening from your forests and trees are really that last mile, but it's really important to still reduce those overall emissions. So that baseline emissions is really important to put a lot of focus on reducing those emissions, not only for greenhouse gas not only for greenhouse gas reductions, but for other benefits as well to help create a more sustainable community. So again, reducing your emissions from your electricity, natural gas usage, transportation are truly important, and this forest and trees outside of forest can add to that, just to help you at the last mile to get to your goal. And I wanted to show a couple of examples, and again, these are examples, as Nancy had mentioned, with that Learn tool that she went over, that we had developed. We did a pilot to help a couple of communities actually go through using that tool and apply it to their greenhouse gas inventories, and plan from there. So one that we're looking at, I'm going to be showing two different examples. This is Montgomery County, and they actually did two of these. They ran the Learn tool twice to kind of look at the change, land use change from 2001 to 2011, and then they did from 2011 to 2016. So as you can see on the left chart, that 2001 to 2011, their standing forests and their trees outside of forests and a little bit of new forest really helped them to remove a lot of the carbon in the atmosphere, but they did have a lot of tree loss. So that red, this red chart bar here is showing that there is a lot of tree loss as well in their boundary. And so that came out to around a net sequestration of 200,000 metric tons of carbon dioxide equivalents. But when they went to did their 2011 to 2016, you can see that they really cut down on the amount of tree loss occurring. And so they still had their standing forests, they still have their trees outside of forests, and but they really cut down on that tree loss. And so now they, from 2011 to 2016, now they have more of 500,000 metric tons of carbon dioxide equivalents that are helping them to reach their goals. So this is an example of a lot of emissions being removed for a community, and something that they can add to any planning that they are trying to pass, like a climate action plan or something, to help reduce their emissions. And another example that I wanted to give is San Jose, California. So for those that are not very familiar with San Jose, California, it's one of one of the largest cities in California, and very settlement heavy. So a lot of commercial areas, a lot of settlement and concrete covering most of the city. And so they also were part of our pilot, and they were also able to include any forest sequestration, mainly from trees outside of forest, that they can include in there, but also the emissions from forest, standing forest, and into their greenhouse gas inventory. And so from this chart, they did have around 100,000 metric tons of CO2 sequestration or removal of carbon from the atmosphere, with about 35,000 metric tons of emissions. So netting that is only around 65,000 metric tons of sequestration. And if we were to put that into perspective with their entire inventory, and this is a public document, so if you want to, San Jose's 2019 greenhouse gas inventory, you can go ahead and look at that document. But if you look at their overall emissions, the forests and trees are only looking at that 65,000 metric tons of removals, whereas their citywide emissions from transportation, natural gas usage, electricity and other solid waste process and fugitive emissions, that amounts to about 5.5 million metric tons of carbon dioxide. And so the forests and trees, I think that this was a good exercise for them to see that, there's still a lot of work to do to reduce the transportation emissions, reduce those natural gas emissions. But the forests and trees can definitely help them to get to that last mile. And so something that they could look into is increasing the amount of urban trees that are in their boundary. And that is definitely one of the strategy that cities will often do is including planting more trees or planting more forest to help with the sequestration. And I think that is it for our session. So I really just wanted to thank everyone for joining our call, and definitely thank Nancy and Rich for providing their expertise in this area. And I wanted to open it up to any questions to just kind of see if there's any questions out there that folks may have. And we can spend the next 20 minutes or so answering any questions that anyone has. And so if you are in the Zoom, I think you can go ahead and type in any questions that you have. Oh, okay. I'm starting to see a few questions come in. So great. Awesome. So I see a question here. What else would you like to do with the tools and methods? So I think something that would be great to do, and again, Nancy and Rich, please, if you have any other answers, please go ahead. But I think a great thing to do is to be able to, after a city is able to account for their forest and account for their trees, any sequestration or removals from that, if you put together that inventory and you put out your overall citywide emissions inventory, next step would be kind of forecasting to see, if you just go business as usual, what would your emissions look like by say 2030 or 2040 if no actions are taken. So forecasting that out, and it would be great to be able to forecast out to see what your forests are looking like. So are your forests, is there any way that your forest can expand, or if there's going to be any type of removals that you can already account for, and that can kind of help you to then be able to develop any tools or any measures to increase your trees and increase your forest. And I just wanted to check real quick if Nancy or Rich, if you had any other points to add to that question.
Yeah, I'll mention a couple, and I think Nancy has some also, because we've thought a lot about this, developed some proposals, and there were things we would have liked to have done this last year that we just couldn't, given resources and time available. Plus, we learned a lot working with the different communities, and so that gave us a lot of insight into, boy, what would be nice to do next. So some of the basic ones are our inventory period only went up to 2016. So, getting the new data from NLCD in there would allow it to go, when's the next date? I think it's 2020 or 2019. I forget which, but much more current. And similarly, updating some of the other data that's essential, such as the disturbance maps that are really having a big impact on forests of the US these days. So kind of updating some of the basic data, improving the output, because there's a lot of interest in digging into the numbers and being able to work with the data after the analysis is run. And some of the information is just not available. For example, one I'd like to see is the area by forest type and age class that goes into calculating the emission and removal factors. We sort of just guess what that is now. It's all in the model or in the tool, but we can't get at it very easy. And I'll mention one more, and then Nancy can fill in what's missed. And that is allowing the user a little more flexibility to upload their own information, either emission and removal factors, maybe they have some maps they'd like to use, whatever, but just providing that kind of customization, if you will, for the user, because the users are pretty sophisticated in a lot of cases, or they just want to use their own information. So, that would be a big help. That's it for me.
Yeah, I'll just add a couple more things. So one thing, in addition to updating all the input layers in the Learn tool up through the current year, or the year that the latest data are available, which in NLCD case is 2019. We also discovered in our pilot community testing that the tree canopy data within the city context, especially using the NLCD tree canopy data, is really not detailed enough to capture the full tree canopy and changes in tree canopy in really urban areas. So one thing that we're planning to do this year is to switch over from the NLCD tree canopy data to high resolution 1 meter tree canopy data. We're gonna pilot for the Chesapeake Bay region first, and provided that type of analysis on this really high resolution data works well, we hope to extend that over across the whole US. So the forest part of the analysis won't change a whole lot, but the trees outside forests will be able to capture a lot more tree canopy and tree canopy change than the current tool allows.
Great, thanks. Thank you both for those answers. And I think we have another question that I think Nancy kind of touched on a bit, and that was, are there other projects coming? And Nancy did touch upon that a little bit. We are hoping to get that Chesapeake Bay data into the Learn tool so that we can start another pilot program, another cohort with, again, 20 communities throughout the US, so that we can pilot this new data and see how much better that resolution is for accounting for their forests and trees. So yes, very, very excited for that next pilot to be coming along.
I see one more question about prairie grass and other vegetation. Maybe I can take a stab, and then Rich and Kaylin can answer it. So right now, the tool and the protocol guidance itself is focused really on the forest and tree component, and not so much the soil carbon component. And that's one thing that we could add into the protocol in the future is, if we're capturing the changes in tree canopy already, but what about these changes in soil carbon resulting from different management practices? That's a lot more complicated and requires some modeling. And there are some tools out there already that capture that. And so the question mainly is, how can we take advantage of what has already been done in modeling soil carbon and soil carbon change and build it into the Learn tool in a way that doesn't reinvent the wheel. Rich, do you have other things to add to that?
No, you covered that really well. Yeah, it definitely. I mean, it's set up to do that, to add that. We just haven't had the priority really up to now to do it.
Great. Thank
Yeah,
you.
I also see a question about can cities sell carbon that they sequester? I think Kaylin covered this at the beginning of what this protocol is designed to do and not do. So this guidance and the tool is really to give communities a sense of what the emissions and removals are, like a magnitude and direction sort of estimate of greenhouse gases from forests and trees. And it's not a protocol to use if you want to sell carbon credits. So generating carbon credits requires a whole different set of parameters. And there are carbon offset standards out there specifically for issuing carbon credits, like the Climate Action Reserve and the American Carbon Registry. This tool and this protocol is not designed for generating carbon credits.
Yeah, it's more of a strategic analysis and not one to enter into some kind of a financial transaction, let's say.
I don't think, though, that any of those programs or standards deal with urban trees. They really focus on protecting forests. I mean, forests are forests, not just individual trees. They have tree planting, they have forest management. There might be one out there with an urban forestry protocol, but I'm not sure about it. So there's not a lot of financial incentive. But on the other hand, cities often have a target, as Kaylin was showing toward the end, in the amount of emissions they want to reduce, which can include trees removing CO2 instead of reducing emissions. And so it can contribute to achieving targets, even if you can't sell the carbon credits. That doesn't mean the tool can't help address that target setting. And I'll look at the next question. How about reducing heat island impacts? Actually, it is possible. Again, it's a strategic tool. But if one used it to, let's say, look at a city and say, well, they've got 20% tree canopy cover, they're losing 10% of that each year. Maybe if they avoided that loss or planted more trees to increase the tree cover, then that would in turn reduce the heat island effect in a community. It's quite well known that trees in an urban area have a very strong cooling effect, and so when you're in a heat spell, if you're in a treed area, you're much better off. And quite frankly, that's one of the big differences in the environmental justice regime, because a lot of the poorer areas have much less tree canopy cover than more wealthy areas, and consequently suffer more during a heat wave. And so, that's really a priority in a lot of cities now, is to try to increase that tree cover because of those cooling benefits.
Yeah, one thing I'll add to that in terms of where that would show up in your inventory. So the Forest and Tree Appendix J is meant to capture only what's directly occurring on the land in terms of forests and trees. And so if a community decided to increase tree canopy to reduce the heat island effect, that would not be counted in the forest and tree inventory. That would show up more on the energy side of, reduced energy consumption via air conditioning, because there's less need for as much energy because you have these cooling trees. Does that make sense?
Yeah, definitely. And I was just going to add that, and I spoke a little bit about climate action plans. We didn't go too much into that, but in a climate action plan, you'll have your greenhouse gas inventory, your forecast, and then a big part of that is planning for what different types of measures you want to include or implement in order to help you reduce those emissions. And increasing the amount of trees and planting trees is definitely something that can help to reduce your emissions and like this question was asking, also reduce those impacts of the heat island effect. But there's multiple other questions that, multiple other measures that you can include in your climate action plan to also benefit your city, and including different biodiversity measures, any type of equity in order to increase equity, and definitely make sure that some of the measures are not having a negative impact on communities. So like if we're talking about tree planting, making sure that we're planting trees throughout the community and not only in certain communities and only giving a benefit to only small parts of the community, making sure it is really spread throughout the community, and making sure everyone in the city can benefit from that. So really those climate action plans are a big part of this effort to reduce those emissions, and especially get more trees, more biodiversity into the city. Yeah, and I see another question here. This question is, what was the biggest surprise from the pilot communities? And I think that I can't remember which community it is, but I think that there was a county on the West Coast who they had most of their emissions, and maybe Nancy or Rich can remember which city or which county it was, but they had most of their emissions that were completely balanced out by their sequestration. So I thought that was really amazing to be able to see that community that was able to almost like claim carbon neutrality from having most of their emissions covered. But a really amazing thing was that they were still planning to reduce those emissions that they still had from their baseline. They're looking at, like, again, electricity and transportation, still reducing those emissions, because it still is really important for, like I mentioned, like public health, something like other benefits that can come from reducing those emissions. And I mentioned public health, just if you're thinking about natural gas usage or vehicles, the exhaust coming from vehicles that can lead to more asthma or something in your community. So making sure that we're still reducing those emissions, not just for GHG reduction, but for public health benefits as well. Was Nancy and Rich, was there any other big surprises from any of the pilot communities that you were really interested or excited about?
And just building on your first comment about depending on your community and its land base and how you set your targets, where you're starting from really matters, right? So if you're a really rural community with a lot of forest cover that is absorbing carbon, and you may not have as high emissions in other sectors as San Jose might, for example. So there may be cases in communities where forest carbon removals are exceeding all of your other emissions from all of your other sectors. Does that mean you're done? No, you haven't done anything yet, right? So the point of including forests and trees into the emissions inventory is not to say, okay, well, we're done, we don't have to do anything. It's to start by counting everything and then adjust the targets so that you can, you want to adjust your target so that you're still showing the ambition and reducing your emissions, and you also have targets to increase the sink on the forest side. So I think that was something that took a while to get through to communities, of just the fact that forests are removing carbon in the first place, right? Because many communities are so used to thinking of emissions, and then there's this removals part. What do I do with this? And so that was a fun experience.
Well, I was very pleasantly
surprised at how far some of the communities took this analysis. And the ones that stand out to me are Montgomery County, which was really in the first year, but they also kept going. They did 2 inventory periods, looked at the changes over time, and really produced just a beautiful report with lots of detail and kind of exactly what you wanted to see. And Jefferson County, Washington was the other one that really took it a long way. They did 3 periods of analysis and broke it down by 5 or 6 different jurisdictions. And just the level of detail that and effort they put into it. They're still asking us questions, so it was just nice to see them really take off, and it always makes you feel like your work is worthwhile when it has that kind of impact. So.
Great. Yeah, I definitely agree. And I see we have one question left, but not a lot of time. So I just wanted to answer this last question on where could we find an intern to help us with this work or partner with a graduate student. And if we partner with universities. So we definitely do partner with universities. So I put this up here so you can reach out to our contact information, so you can reach out to us for any questions. If you wanted to possibly participate in this cohort, we can definitely kind of discuss that with you, but definitely reaching out to nearby communities, and we can also work on any type of university collaboration for this project. So thank you all for all of these questions, and thank you for the time. And we are exactly at time. So I wanted to again thank Nancy and Rich for being a part of this presentation with me. Thank everyone that is either watching now or watching the recording. Thank you all so much. And please, if you have any questions or want any information, please feel free to reach out to us.
All right, now, thanks for doing a good job of keeping it all going, Kaylin.
Awesome. Thank you, everyone.
Thank you very much.